Welcome to this module on HVAC system design for oral solid dosage manufacturing facility. This standard describes the minimum design expectations for heating, ventilation, air conditioning system design for oral solid dosage manufacturing facilities are appropriately considered during the design and execution of projects. This design guideline defines the design expectations must and recommendations should to ensure that the resulting HVAC systems are suitable for use in Teva's oral solid dosage manufacturing and packaging facilities. In this module, you will learn about design expectations and recommendations, system boundaries, general system design and requirements, approach on system capacity basis, individual system components, design requirement capturing major elements for HVAC system design for various level of protection, specific topics covering basic information for monitoring and controls, GMP requirement, safety consideration, energy saving and conservations, commissioning and qualification, system maintenance, documentation. Design expectations and recommendations in this module are based on accepted industry practices. The following internal and external documents were consulted in the preparation of this guideline. Click on each item to know more. Design of HVAC system must be in accordance with local laws, codes, regulations applicable to Teva's OSD manufacturing sites. Where there is a difference with this guideline, a more stringent standard must apply. When metric units are provided, their non-metric equivalents can be used at the designer's discretion. The HVAC system battery limits are from the point of intake in the air handling units to the point of air exhaust to the atmosphere. Supporting systems such as hot water supply, chilled or cold water supply, or purified water supplies must be included in the HVAC system from the point on the nearest isolation valve or element. Examples: CWS or HWS from the coil isolation valves is within the HVAC limits. PW supply for humidification. Use point and the check valve after it is a part of the PW system. All valves and other elements after the check valve are within the HVAC battery limits. Air intake nets, louvers, and filters. On outside air, intake louvers, preventing or minimizing rain entering the AHU should be installed. For regions expecting dust or sandstorms, sand trap louvers should be installed on outside air intake. Typical air handling unit. The following is the general information about the construction of the system AHU. Specific design details for AHUs are provided in General Facility Air Handlers Unit Design. A typical AHU should have fine-grade filters M5 and above, installed before the fan and coils, and a minimum fine-grade final filter before the supply duct. Click here to view the filter classifications. AHU panels must be constructed of suitable materials and with sufficient insulation based on the AHU location. AHU drain pans are required in cooling, heating coil, and humidifier sections for cleaning or maintenance, or for a leakage during operation. AHU coils should be designed in such a way that it allows easy access to the coils for maintenance, example cleaning. AHU fans must be installed in a direct drive arrangement, with the motor connected to a variable speed drive. In the below given HVAC diagram, can you identify the components? You have 30 seconds to complete this exercise. Drag each tile placed on the right-hand side and place it on the dotted boxes to identify the component and then click Submit. Drag each dotted circle and drop it on the blank circle on the left to learn about air circulation and recirculation. HVAC systems must be designed to provide grade D for all classified rooms within the HVAC scope. Once through versus recirculated, both design approaches are acceptable and should be evaluated on a case-by-case basis. Recirculated air system should have minimum outside air intake. It should be higher of air required for room pressurization control, applicable local codes. Any design approach must address cross-contamination prevention, cleanliness and protection of the product, product-specific properties and characteristics, operator safety and comfort, environmental protection, energy efficiency. Air must not be recirculated from areas where solvents are used. To revisit, click on each button, or click on the next button to continue. HVAC systems must be designed to provide grade D for all classified rooms within the HVAC scope. Once through versus recirculated, both design approaches are acceptable and should be evaluated on a case-by-case basis. Recirculated air system should have minimum outside air intake. It should be higher of air required for room pressurization control, applicable local codes. Any design approach must address cross-contamination prevention, cleanliness and protection of the product, product-specific properties and characteristics, operator safety and comfort, environmental protection, energy efficiency. Air must not be recirculated from areas where solvents are used. To learn about humidification and dehumidification, drag and drop each labeled box onto the empty box. Humidification is required for all areas within the OSD manufacturing facility. Clean steam must be supplied from a clean steam generator. PW or equivalent water must be used. All surfaces that come in contact with the steam from the generator to the supply point must be 316L mil finish stainless steel. All connection must be welds or tri-clamps. No threaded connections should be used. Steam quality should be periodically tested. For details, refer to GEM's Guideline Humidification Dehumidification Systems. Dehumidification should be achieved via AHU cooling coil. For RH lower than 40%, solid desiccant dehumidifiers should be installed. For details, refer to GEMS Guideline Humidification Dehumidification Systems. Before you proceed, can you answer this question? To learn about HVAC system capacity, click on each labeled button. Cooling. HVAC systems must be designed for continuous operation under extreme environmental conditions. Refer ASHRAE Weather Data Design Condition or local metrological design data conditions. Extreme temperature and humidity conditions available at the time of the system design must be used while designing or sizing cooling or heating coils, or AHU or ducting thermal insulation, and other HVAC components. HVAC system must not exceed its maximum operating range due to external temperature and humidity fluctuations. Air change rate. HVAC system should provide typically minimum 15 air changes per hour for production areas. This includes primary packaging areas. HVAC system should provide a minimum of 10 air changes per hour for airlocks, corridors, and other CNC areas. Design. The system recovery time is the time it takes for a system to achieve the desired temperature. Humidity and pressure conditions in the facility must be clearly defined. This should be calculated on a case-by-case basis, taking into account manufacturing requirements, product exposure, and other parameters relevant to the site. HVAC system must be designed with 5 Pascal, 0.02 inches water column higher than required room design, differential pressure considering the accuracy of instruments, variation in gap across the door, the undulation of floor, etc. System and equipment. AHU and exhaust fans must be appropriately sized to allow system operation with filters at 70% choke conditions at their final pressure drop. Duct and room air leakage must be taken into account. While the duct air leakage must be minimized as much as possible for design calculations, only a minimum value of 6% of the total air volume should be used. HVAC system should have a 15% excess capacity. In the individual system components, let us first look at high-efficiency particulate air, or HEPA filters. HEPA filter must be installed with ports, allowing integrity and differential pressure testing. Ports can be located on the HEPA filter frame or the filter housing. Click on each label button to learn about OHC groups. For OHC Group 1 to 3, HEPA filters on the HVAC system supply should be installed in the supply duct or in the AHU. It is recommended to install HEPA filter at terminal location. Exhausted air must be filtered in accordance with the local environmental regulations. For OHC Group 4 to 6, terminal HEPA filters must be installed flush with the ceiling for supply and the exhaust or return duct at the room boundary. All air exhausted to the outside must be HEPA filtered. The filter should be bag-in, bag-out type. Additional police HEPA filter must be installed before the air is exhausted outside. Exhaust or return should be bag-in, bag-out type housing for personal protection. Click on each numbered button to learn about ducting. The ducts should be perfectly smooth and sealed inside and stiffened to prevent any vibration and sway. They should be made out of hot-dip galvanized sheet steel. Transitions from one cross-section to another should be made at an angle of 45 degrees or less, or otherwise fitted with directional vanes. The radius of the bends should be equal to or greater than the width of the duct or otherwise fitted with directional vanes. All ducting must be appropriately grounded in accordance with the local codes or regulations. Exhaust or return grills should be located near the floor as much as possible to ensure good air circulation in the suite. Installation of internal insulation is not allowed. Installation of rock wool or similar design silencers is not allowed. If a silencer is required to maintain appropriate sound levels, it should be an all-metal construction.